So our next presenter is from Tata Trombay Civil, bottom as concentrate TetraPod, best cement product from waste material.
Morning everyone, this is Vijay Kotalgi. Today I am presenting one of the innovation project which is done by our Trombay Civil Estate and Land Monetization Department from the Tata board, which is bottom mesh concrete TetraPod. It is an implemented innovation. This is how I will be taking you through the entire course. The problem statement, solution offered on it, solution implementation, financial benefits. And why we call this idea is a unique and innovativeness, this is explained, and possible impact after it's a post-commercialization. This is a team details, myself Vijay Kotalgi, from idea inception to the execution, all the activities are handled by me under the guidance of Mr. Uttam Bhavskar, and this project is done at Tata Trombay Thermal Power Generating Station. This is about charter detail. Project started was in October 21 and project we have successfully completed in January 2022. As it is a totally developed in-house, we have not hired anyone from the external agency, and it is first in its kind in the Tata Power and even in the power industry. Hence we applied for the patent. Till time this project is shared in the Confederation of Indian Industries, where we have received Platinum Award for our project, and we have discussed this project in our annual ash utilization. These are the project deliverables. What we are achieving after implementation of this project. This is a gainful utilization of the bottom ash, cost saving, and the sustainable development steps towards the sustainable development, which is in line with the today's theme organized by Society of Power and Energy Professionals. Let's have a look on the problem statement. As we know that all the thermal power plants are running on the coal, and when we burn the coal in the power plant, in the boiler, then there are two byproducts are formed. One is a bottom ash and another is a fly ash. We know the fly ash has a definite, and now at this moment it has a definite market, and it is being used by the cement industries and also in a ready-mix batching plants. But at other hand, another product which is a bottom ash, it has not a definite use at this moment and across all the thermal power plants. As we know, the coal burning is a continuous process and bottom ash is being generated on a continuous basis, and generally it is considered as a waste product, and it requires a large space for the storage, and it is needed to be disposed of under the guidelines of the MPCB, which involves the huge statutory compliances, and the huge cost expenditure is involved in this bottom ash disposal. On another hand, our always the business objective that management is always looks for the cost reduction and creating something based from the waste, and always they are looking for the gainful utilization of the bottom ash as much as possible. So this is our present scenario at Trombay Thermal Power Station. The annual ash generation is near about 6,000 to 7,000 metric ton. And we are doing expenditure of near about 1 crore for the disposal of this bottom ash, and this bottom ash is being disposed at near about 40 to 45 kilometers away from the plant under the area approved by the MPCB with maximum statutory compliances. Also, we have started using this bottom ash for the landscape development and various non-civil works in our plant area. Now, solution offered. This slide will explain why we have chosen the TetraPod for this usage of bottom ash, because TetraPod is a single largest civil article which is used as a energy dissipator, and when we keep into the staggered manner, and it also acts as a wave absorber. Raw material consumption is very high in the TetraPod as compared to the other civil articles like a brick and you can say a paver blocks. Hence, we have chosen this TetraPod, and initially, along with this, recently in a last monsoon, we have suffered some the land erosion at our sea coast, and collectively we decided to use this bottom ash to make a TetraPod in-housely. This concept was totally unique for the power industry because to the best of our knowledge it is not done by anything that is TetraPod, which is done using bottom mesh. So we started the implementation of the solution. The bottom mesh TetraPod is a tetrapod made using waste material from the coal thermal power plant. Here you can see the conventional tetrapod has a composition as a cement, sand and aggregate, whereas the bottom mesh tetrapod has a composition of cement, bottom mesh and aggregate. To go ahead with this our solution, we have defined some engineering parameters for this particular job. That is, we have fixed the grade of concrete as a M30 and we were doing it first time, hence we did some reinforcement in this bottom mesh. Raw material, as we decided, it is a cement, pond bottom mesh and aggregate, and generally the standard weight of bottom mesh is varying 2.5 metric ton. It is ideally being used at various sites. Here you can see bottom mesh we have removed from the ash pond. You can see the quality of bottom mesh. It is as good as a natural sand because we are using imported coal. Hence, the quality of bottom mesh which we are getting, it is near about sand. This is the tetrapod mold. Here we brought the mold on the side. Reinforcement caging done inside the tetrapod, and that mold is ready for the concreting. To get a better mix, we did mixing with drum mixer mechanically. And we casted the tetrapod. As we were doing it first time, deshattering was done after 48 hours of curing. And here you can see the TetraPod's first tetrapod, bottom mesh tetrapod is ready. And we have observed very good finish, homogeneous, crack-free and sandless bottom mesh tetrapod. After getting success on the first product, we did a multiple castings. And this is first batch of bottom mesh tetrapod, which is done replacing 100% sand from the cement composition. That is the concrete which is we are doing. It is a sand, cement, sand and aggregates. Now we are replacing that sand completely by the bottom mesh. Here you can see the earlier course, which was our Kolberg jetty. It was having some erosion, and we have placed that newly casted bottom mesh tetrapod at our shore. To get support for this, whatever innovation we have done, we did some engineering calculations also. These are the mix design was done. Then we carried out some compressive quiff strength. And here you can see the strength which we were decided it was M30, that is 30 Newton per meter square. And actually what after testing we got, it is near about 35 and 37 Newton per mm square. It is as good as a normal conventional concrete, and even we are getting more strength for that. Also, as we know that bottom mesh contains some metals in this, also it contains some chlorides. To get satisfied with the quality of that tetrapod, we carried out some chemical analysis of the bottom mesh which we have used from the NABL aggregated laboratories, and we found all the parameters are below the limit.
But what are the main chemical constituent of bottom mesh?
Sir, bottom mesh is unburned coal, okay, which is deposited at the bottom of the furnace. Okay, it has a chlorides, main component is a chloride, and another like sulfur. All these components we have tested it, and the limit which is fixed by the as per IS codes, and limits which we have got, they are below the IS code, means it is safer for the use.
Any silica is there, SiO2?
Yeah, it is there. Yeah.
Probably their imported coal it is lesser.
Yeah.
Other Indian coal, silica may be more.
The silica is definitely going to help for confidence.
We carried out some cost analysis for this. For this 2.5 metric ton of TetraPod, we have used near about 785 kg of bottom ash. That is, we have saved 785 kg of natural sand. And as we are using bottom ash for the casting of TetraPod, so straight away there will be reduction in the disposal of bottom ash. So when we consider the plan for the thermal power plant, for the Trombay location, we will straight away saving near about 77 lakh in a disposal of bottom ash per year. Also, if we go for the commercialization, if I give this bottom ash to the external manufacturer who is manufacturing the TetraPod with some standards which we have considered, that is within 50 kilometer periphery from the thermal power plant. So straight away we are saving near about 3,400 rupees in a production cost of the TetraPod. Now this is comparison done from the Trombay thermal power plant, entire Tata Power and all India level. So you can see we are getting huge numbers. Means there are a lot of calculations we have done for arriving this table. But the main that we are saving billion tons of sand, which is used for the casting of tetrapods. Now we are replacing it with bottom ash. So there will be a saving of billion tons in the sand exploration. Now you can see the tangible benefits and intangible benefits. As we are saving near about 100 rupees per metric ton in a disposal of bottom ash. Then saving in tetrapod production cost is near about 3,400 rupees per tetrapod and billion tons of the sand exploration. Also, it has a intangible benefits, like we have done the best product from the waste material of the thermal power plant. Also, steps towards sustainable development by saving natural scarce resource. Steps towards sustainable development by reuse of waste material. And saving in material procurement cost, because bottom ash is easily available at all the thermal power plants. Hence, we are saving the material procurement cost. And non-exploration of sand will prevent erosion of river beds and another flood activity. Now, why we are calling this very innovative? Because bottom ash tetrapod is a tetrapod made using waste material of coal-firing thermal power plants, whereas you can see the conventional tetrapod has as I explained earlier, cement and sand and aggregate. So we have replaced the sand part, which is a fine aggregate in the concrete composition, totally by the bottom ash. As there are many products available in the market, but they have done part replacement of sand, means sand is replaced by 50%, 30%. But in our case, we have replaced it totally by bottom ash.
100%.
So it is total 100% replacement, and here majorly it is a breakthrough in civil engineering. And to the best of our knowledge, nobody has done at this moment. So we have applied for the patent in the month of May.
Excellent. Excellent.
So what will be there after means possible impact after commercialization? Here you can see India has a coastline near about 7,000 kilometers, and everywhere during each monsoon we are seeing that coastlines are getting damaged. So there is a loss to the property, loss to the human life. Also, when we think about the inland activities, there are excessive sand mining is happening, and also that sand mining is that related to the flood. So there is a lot of scope available for this bottom ash tetrapod to cast the tetrapod and use here for the seacoast protection and river draining activities. Now recently we know that governing bodies, they are banning the sand mining. Hence there is always production of the tetrapod has come down because there is a restrictions for the sand mining. But on another hand, in India, near about billion tons of bottom ash is available at this moment. Hence, we can easily cast that tetrapods and we can use it for the various activities. For this, we are doing some study and business model and tie-up with the government agencies. So we can implement this for the seacoast protection projects, river draining projects, major government undertaking projects, and new islanding projects. Now which that is planned, that statue of Shivaji Maharaj in sea. So like in that project we can use this type of product. Now at this moment we have implemented this concept on the pilot project, at our Kolbar jetty. Now we are observing impact of seawater, actual impact of seawater on this TetraPod, and we are sure ki it will behave as good as a normal conventional TetraPod. Now for the horizontal deployment, we are going through within our organization to another thermal power plants where a lot of water mesh is available, and already discussion for that it is in line. Also we are developing business model with government authorities for replicating it to the all thermal power plants and scale up to the maximum productions. And also last month our environment department has already in line with that MPCB Maharashtra Control Board, and they also appreciated this activity, and we are taking it ahead for the next level. This is all about the projects.
Excellent.
Thank you very much, sir. Questions?
I have only one question. That is a general knowledge question. For this kind of wavy nature, this coastal area and all that, and when I go to Marine Drive and I see that tetrapods are used. So why tetrapods are required? That waviness of water. Can you kindly tell me why the design of of stopping the waviness, or what we call it?
Low tide
Impact.
The impact of that. Why this particular tetrapod shape is used? Any idea? Any research on that?
That tetrapod, it has a 4 legs.
Yes.
And when we put into the interlocking mode to get that particular interlock, so by its self weight, it stands itself on the place.
Okay.
So that's why we have chosen, because the raw material consumption in this tetrapod means it is very high. Okay. So by its self weight, it will stand at the place, and it will act as a wave absorber, energy absorber, whatever wave is coming. So because of its self weight, it won't allow water to reach up to the shore.
Yeah.
So it avoids the erosion of that particular shore.
That is, the shape itself is biting. It is stable.
Yeah.
And then they stop it.
We didn't require any external like techniques. Only the shape will help us to make it happen.
Thank you.
In the business model, you have taken cognizance of the transport cost.
Yes.
More than 1 ton weight per tetrapod. So
Yeah.
from the thermal plant or wherever it is cast and where it is used, the transport cost will be substantial. So that should go in the business model.
Yeah. Sir, actually when we did some analysis for our Trombay thermal plant, we are spending near about 1,300 rupees for the transportation of water mesh from one place to another place. Okay, so we have chosen that case. So when we take a cost of that raw material sand, which is available at 6 rupees per kg, and when we compare, so we are even at that when we replace that sand with the water mesh, even with that transportation, so we are saving substantial amount. So for this case, for the Trombay power plant, it is we are in positive note, and we are also working for the another plants. So that will be considered in a business model.
So we have sometimes 1 minute only. So any other question you can take, because he has finished before time.
It is a great utility, bottom ash.
Yes, sir. Yes, sir.
Excellent.
And it is solution provided to all the thermal power plants, because most of the thermal power plants are facing the same problem of water mesh disposal. They are because it has currently no value at this moment, and they are just storing at their land. So now we have given a solution that you can utilize this water mesh for this making tetrapod.
Even storing is a big problem. Such
Yeah.
huge bottom ash, where to store?
Right, sir. Thank you. I think there is no question. I have one minute.
Yes, we have asked. Just a small suggestion, if you are doing so much of innovation, people have started using bamboo as reinforcement these days. So maybe as a next step you can even try that. So then steel also will be saved if possible. I
Yeah.
am not sure about actual utilization, but a lot of research is going on abroad at present on using bamboo as reinforcement.
as a reinforcement steel.
But TetraPod is very popular.
Bamboo is a re-
Yes.
TetraPod is very popular for reinforcement.
But sir, production of TetraPod is very limited because government is, whatever the governing authorities, they are banning the sand exploration. So raw material is not easily available. Even they are banning the exploration of mines, means
You
stone quarries.
should push to replace that sand
Yeah.
with the bottom ash. You
Yeah,
must
yeah.
push.
Okay, fine. So, I think it is over now.
Yes.
So only I want to add 2 points. One question asked is what is ash? In coal, after burning coal, which doesn't burn is ash. So in the coal, whatever you have which doesn't burn is coal. It can be silicon, it can be other materials also. That is one point. Second point is about.
I would like to add one more point there.
Yeah, please.
It is not that when you are extracting the coal from the mine, ash is already there.
Yeah, ash is part of
So
the
it is
coal.
coming
It is
contaminated
already
when it
there,
comes.
and sand is also part of ash. And second thing is that the questions, whatever you told about the piling. See, bamboo as a piling material is used in Northeast as well as in Bangladesh. So it is used as a piling material for quite long time. It is a long history. Why it is used? Because it is cheap. I have seen it in Tripura also, because bamboo piling is used because it is cheap. And shifting TetraPod from Mumbai to Tripura, I do not know whether it will be cost effective or not.
No, but this Trombay, Tata will make a plant at that.
Yeah, right, sir. Thank you very much, sir, for a very good wish and very good blessing. Definitely, we would like to see that. Thank you very much.